did inverses back in Algebra 2. So depending on what you remember, this may seem very familiar, and if you're good with it, I can skip things, but I like to go into it assuming you remember nothing and giving you all the information. Okay, so first thing, there's a definition on here. It says one-to-one functions. So if I'm talking about one-to-one functions, what that says, I think I slightly reworded it on your handout. Two different domain values give you two different range values. Actually, I know I say, hold on. So one-to-one means two different domains give you two different ranges. In other words, we know if it's a function, x doesn't repeat. If it's one-to-one, that means y doesn't repeat. Okay, if you give me two different x values, they have to give you different y values. That's what makes it one-to-one. So first I just want to look at a couple different ways the functions might be represented and see if those are one-to-one. All right, so this first one, I just gave you a mapping. So this is like your x and this is your y. Would this be one-to-one? No. We can see right here that 38 gets repeated. So a lot of times I just do 1-1 to represent one-to-one. That's kind of my shorthand. So because that 38 repeats, it is not one-to-one. Is the second one one-to-one when I gave you that folder? Yes. We look, they all have a different y value, so that one is one-to-one. All right, there are different ways of deciding if functions are one-to-one. If I give them to you like this, it's easy. We can just look at the points. If I give you a graph, it's pretty easy. We'll talk about that in a second. But if I give you an equation, we have to understand how to get there. So there's two ways. There's a graphical way and an algebraic way. The algebraic way says, okay, we know that if it's one-to-one, y doesn't repeat. So we are going to pretend y does repeat. So we will assume that f of a equals f of b. In other words, I'm going to pretend that I'm going to plug in an a and plug in a b and they give me the same y value. And I'm going to see what happens when I do that. So if I looked at this, the algebraic way says we have to start by saying f of a equals f of b. That's just saying the y values are equal. Okay, so f of a would be negative 3a plus 7 equals f of b would be negative 3b plus 7. So we're getting the same y value both times. So let's solve this equation. If I wanted to get a by itself, you subtract your 7, then what would you do? So I started out by saying, okay, these y values are the same, and what did I get? A equals b. So that's saying the only way the y will be the same is if you plugged in the same number to begin with. So if you get a equals b at the end, that's saying this is one-to-one. Because we pretended we got the same y value twice, and we saw the only way that happened is if x was the same. Let's try another one. So if I'm trying to decide if this is one-to-one, we start out assuming that y does repeat. F of a equals f of b. How do we get rid of a square root?
Square it.
And then what do we do? I would subtract my 49s first, but it doesn't overly matter. If I subtract my 49s, those cancel. So negative a squared equals negative b squared. Divided by negative 1. So a squared equals b squared. Then how do you get rid of a square?
Square it. Or square root.
And when you add a square root, what else do you need?
Plus.
So I get A equals plus or minus B. In other words, if I've got the same y value out, I could have put in the same number, or I could have put in opposites. I could put in 1 and -1, and they give me the same y value. So is that 1 to 1?
No.
No. So if you get A equals B, that means it's 1 to 1. If you get anything else, it is not 1 to 1. Another option, if you don't like this, I mean, for some people it makes sense, but for some people this is very abstract and kind of hard to wrap your mind around. We could think about a graph. We know that in a function, x doesn't repeat. So how do we look at a graph and decide if it's a function? The vertical line test. So in a 1-to-1 function, y doesn't repeat, so we would check for the horizontal line test. So if a horizontal line hits it only once, then it's 1 to 1. But if any of your horizontal lines would hit it more than once, it would not be 1 to 1. So let's just confirm this with the 2 examples that I did. If you graph negative 3x plus 7, what's that look like? Just a line. So does any horizontal line hit that more than once? No. So that's 1 to 1, which is what we decided. My second one was the square root of 49 minus x squared. When I look at that, would a horizontal line hit it more than once? Yeah, we have lots of options. It's like a semicircle. So I could draw a horizontal line that hit it more than once, so it is not 1 to 1. So we have the algebraic, we have the graphical. I put a couple on here that I would like you guys just take a second and decide on your own. You can use the graph, decide if each of those are 1 to 1 or not.
Unless the graph goes.
X squared. I know that's just a parabola. Is that 1 to 1? No. There's lots of places you can draw a horizontal line that hit them multiple times. What about B? That's the chair function. No horizontal line hits it twice, so that one is 1 to 1. Are we okay with what it means to be 1 to 1? So 1 to 1 is important because if something is 1 to 1, then we can find what is called the inverse. So the inverse is really just like the opposite of something. So if I said x plus 5, what do you think the inverse of x plus 5 would be? X minus 5. It just undoes the operation. Now we need things to be functions, or to be 1 to 1 in order to have an inverse, because what happens is we really switch x and y when we find the inverse. And if the original wasn't 1 to 1, then your inverse would not be a function. We use this f to the negative 1 to represent inverse. We're used to negative powers, meaning flip it. This is a slightly different notation. So if you have f to the negative 1, that's just talking about the inverse of a function. So let's start with just a listing of ordered pairs and finding the inverse. So here are my points. When I find the inverse, what would I have to do with each of those points? It's just flips x and y. It doesn't change the sign. So if the original point was negative 3, negative 27, the inverse is
27.
Negative 27, negative 3. You just change the x and the y. So my next point would be negative 8, negative 2. Negative 1, when I flip that, it stays the same. 0, 0 stays the same. 1, 1 stays the same. What happens if you flip 2, 8? So if I give you the points, all you have to do is reverse them to get the inverse. So if I'm looking at that, the domain in my original, those were my x's, -3, -2, -1, 0, 1, 2. What are those in my inverse? The domain in my original becomes what? The range of the inverse, because x and y flip, so your domain and range flip. The range of the original gives you the domain in your inverse. So when we start finding these, we'll be doing domains and ranges, but it's really not 4 separate things you have to find. It's really 2 of them. So the domain of the original function, the x's in the original, they become the y's, so that's the range in the inverse. The y's in the original become your x's, so the range of the function becomes the domain of the inverse. You guys understand that part? So another property with those, put it away. So a function and an inverse are opposites of one another. So the example I already used, if I said x plus 5, we said the inverse would be x minus 5. Okay, so what happens if we do both of those? Give me a number. 7. 7 plus 5 is 12, minus 5 is 7. All right, what if I subtract it first? 7 minus 5 is plus 5, 7. So if you do both the function and the inverse, if you do your compositions, you should get x for your answer both times. They're opposites, they undo each other. So if you do both operations, you should get what you just started with. If I take a number and I add 5 and subtract 5, I get my original number back. So we could use this to check if functions are inverses of one another. So let's look at this one. I want to decide if these things are inverses. So what we are going to do is check to see if I do both operations, do they cancel each other out? You do actually have to check both. So we're going to do f composed with g and g composed with f. And what answer do I want both times? X. If I get anything else, they're not inverses. If both turn out to be x, they are inverses. So f composed with g. Remember when we do compositions, we start on the inside. G is 1/2 times x plus 3. So I'm going to plug that into f. So f is 2 times whatever I plug in plus 3. And plugging in the 1/2 x plus 3. So 2 times 1/2 is 1, that cancels. So I get x plus 3 plus 3, which is x plus 6. What does that tell me? They're not inverses. Do I even need to check the other one?
No.
No. As soon as I see that, I did not get x out, so these are not inverses. They are not opposites of each other. Let's try a few more.
How did you get x plus 3 plus 3?
So when I plugged, are you okay with this step?
Yeah.
Okay. So then I did the 2 times 1/2, which was just 1, so those canceled. So then I had that x plus 3, and then the extra plus 3 on the end.
Okay.
So let's decide if these are inverses. So we have to plug them into one another. So if I do f composed with g, g is 1/x plus 1. I'm plugging that into f. So f is 1 over whatever we plug in minus 1. So when I look at this, 1 over x plus 1 minus 1, what happens? Those cancel, so I get 1 over x. To divide fractions, we flip and multiply. And what does that equal? Now, that's not enough to say they're inverses. If one of them doesn't equal x, you can say they're not. But it is possible that one might and the other doesn't. So we need to go ahead and check the other direction. We need to check G composed with F. So F is 1 over x minus 1. I put that into G. So G is 1 over whatever we put in plus 1. Do you guys remember doing these at all last year? Yeah. Okay. So to divide by a fraction, flip and multiply. So 1 times x minus 1 over 1. So I get x minus 1 plus 1, which is x. So both of these came out to equal x, which means they are inverses. Now, if this really confuses you, we will have another way that we can check to see if they're inverses that we'll get to in just a minute. But I would like for you guys to understand that inverses are supposed to cancel each other. So if you do both operations, you should get out what you start with. So if we do both, we should get just a plain x. Why don't you guys try the next one for me?
Did you say we just want to get x all the time?
If they're inverses, both have to equal x. If one of them doesn't, then you can stop and say they're not inverses. So F composed with G. So I have to go to F. I'm plugging in negative 1/3 times x minus 4 plus 4. What'd you guys do first here?
3 times negative 1/3.
Okay.
Negative
1 times x minus 4 plus 4. So negative x plus 4 plus 4. So did we get x? No. So do we need to check anymore? No. So I know already these are not inverses. We don't have to check the other way. Okay, so like I said, if this is confusing to you, hang on about 5 minutes and we'll talk about another option, okay?
I didn't get that answer, but I also didn't get x. Yeah, what's the x?
So you basically just forgot to close that parenthesis there. All right. In terms of graphing, because an inverse just flips x and y, they are always symmetric across the line y equals x. I know you talked about this because I know when Mrs. Keller had you graph functions in inverse, she always had you draw that line and kind of look to check if they're mirror images. I don't emphasize that quite as much, but I do want to just talk about what a graph would look like. So if I started with the line y equals 3x minus 2, how would I graph that line?
Down 2.
Start negative 2, and then my slope is?
Up 3 and 1.
Okay. And if you need more than 1 point, you know, you can just keep repeating that. Because I can't draw straight lines, so I have to. Okay, so if I graph this is my original function. If I wanted the inverse, we could really just take these points and flip x and y. So if we think this is the order pair 0, negative 2. So what point is it on the inverse?
0, 2.
You just changed the order, not the signs.
Yeah.
So it'd be -2, 0. This is the 0.11, so on the inverse it's still 1, 1. That's enough for a line, but if you did more, you could even check those. So we had 2, 4, so that would go to 4, 2. So this is the inverse. So in graphing an inverse, all you have to do is find some points on the original and flip them. The line y equals x is the line with a y-intercept of 0 and slope of 1. If I drew that in the middle, then we can see that these are symmetric across that line. In other words, if I folded my graph on that green line, would my red and black lines overlap one another? Yes. So that's just a quick check if you're looking at a graph to kind of visualize that line and see, does it look the same on both sides? But as far as graphing the inverse, all you really have to do is take some points and flip them. So I put one more on here with the graph. So I gave you the original graph, and I want to get the inverse from that. So what do I need to do?
Find the points.
Yeah, just find some points on this graph and flip them. Okay, so just take a few points here. So the first point on my graph I have is -2, -2. So when you flip it, it stays the same. Then I have -1, 0. So that would be 0, -1. I have 1, 2. So that would be 2, 1. So my blue line here is the inverse. If you graph the line y equals x, it goes straight through the middle. So you can kind of check that. Is that okay? Now I want to get into the main part here is finding an inverse. What do we have to do in order to find an inverse algebraically? All right, can you guys bear with me just a little bit longer? Promising a work day tomorrow, so it's worth the whole day of notes, right? So, when we find an inverse, for getting the equation, the first thing we will have to do is, if it's written in function notation, we'll change f of x to a y, so that we're looking at an x and a y in our equation. And what an inverse does is it flips the x and the y. So that's the second thing. We'll flip our x and y. We want an equation that we can graph, so we usually like y equals for that, so then we will solve for y. And then the final step, we want to change it back to function notation. And so to show that we have found the inverse, we will change our y to f inverse of x. So that's the 4-step process we'll do. Change f of x to y, switch x and y, solve for y, and change it back to the inverse. Sound familiar at all? Maybe, maybe not. So I'm not boring you to death by going through all this. So we'll do a few examples of this. Let's start off with a fairly nice one. F of x equals 2x plus 3. So step 1 is change f of x to y. So it's just y equals 2x plus 3. Step 2 is what? So every y becomes an x and every x becomes a y. Step 3 is to solve for y. So if I'm trying to get my y by itself, what would we do?
Add the 2,
Subtract the 3 over
and
and divide by 2. So we get y equals x minus 3 over 2. And then final step, instead of y, what do I want you to write?
That's the first one.
So that is my inverse. I'm going to ask you to find domains and ranges for the function and the inverse. What I usually do is I put a little subscript, tell me that means domain of f and range of f. But we know the domain of f is equal to what other thing?
you see.
The domain of the function equals the range of the inverse. So you're not finding 4 separate things. The domain of the function is the same as the range of the inverse. The range of the function is the same as the domain of the inverse. Okay, domain of the function, if I'm looking at the original, there's no fractions, no square roots, it's just a line. So what's your domain? Ranges are sometimes a little bit harder for us to notice, but we could just look at the domain of the inverse. It's a fraction, but the bottom is just 2. Does that ever equal 0? So what's your domain? So in this one, they were all negative infinity to positive infinity. Okay. Let's do another. So step 1, instead of f of x, we write y. Step 2, we do what?
Change the x one.
So this y becomes an x. I have 2 x's, so they both become a y. We need to solve for y. So I will, let's multiply over the y minus 1. So we get xy minus x equals 2y plus 1. I'm trying to solve for y. I have more than one, so I'm going to put them on the same side. So these aren't like terms, we can't actually combine them, so we just have xy minus 2y. We need to add over my x equals 1 plus x. What can I do here?
Divide the x.
Close. Before I divide,
Then divide the 2.
what do they both have?
Take out
If I take out the y, then I have y times x minus 2. So now you can divide by the x minus 2. And final step, how do we show we found an inverse? Instead of y, we write
Yep.
So, domains and ranges. I know the domain of the function is the same as the range of the inverse. The range of the function is the same as the domain of the inverse. So let's start with the domain of the function. The original function, we had a fraction. We know that in a fraction the bottom can't be 0. So what can x not be in this original?
So use 1.
Positive 1, right, for the original, yeah. So my domain is everything except 1. So it would be negative infinity to 1, union 1 to infinity. Okay, it's a little bit harder to find the range by looking at that, but the range of the function is the same as the domain in the inverse. When I look at the inverse, what can x not be? 2, because the bottom can't be 0. So that one is negative infinity to 2, union 2 to infinity. All right, we just did a lot there. What questions do you guys have for me? So f of x equals x plus 5 over x minus 3. So finding the inverse. The first step is, instead of f of x, we have to write y. Then what do we do?
All the x's and the y's and the y's.
Okay, just switch. So the y becomes an x and the x's become y. And then we want to solve for y, so we're going to multiply by the denominator. So we get xy minus 3x equals y plus 5. We're trying to solve for y.
Subtract the y.
I'll add this 3x. So we get xy minus y equals 5 plus 3x. Then what could we do? So then to get y by itself, we would divide. So our final step, instead of y, we write f inverse of x. It's 5 plus 3x over x minus 1. Then I wanted domains and ranges. So the domain of the function we know is equal to the range in the inverse. Range of the function is equal to the domain in the inverse. In the original function, what can x not be? X can't be 3. So the domain of that would be negative infinity to 3, union 3 to infinity. With the inverse, what can x not be? So the domain of the inverse is negative infinity to 1, union 1 to infinity. Questions?
How do you figure out the range?
Instead of trying to think about the range, I just realized that the range of the function is the same as the domain of the inverse. So I go to the inverse and just find its domain. So the bottom can't be 0. So really I just do the domain twice instead of thinking about the ranges. All right, other questions? So the last 2 examples on here are just thinking problems, not really anything that we have to calculate. All right, it says, suppose f of x is the number of cars that can be built for x dollars. So that's saying in the original function, my x was the dollars and my y was the number of cars. So in the inverse, what happens to those ordered pairs? They flip. So in the inverse, the x is the number of cars, and y would become the dollars. So when I ask what f inverse of 1,000 represents, 1,000 is the x in the inverse, and x in the inverse is the number of cars. I'm asking you for the y, which is the dollars. So f inverse of 1,000 is the cost, or dollars, to build 1,000 cars. Okay, so just thinking about what those numbers represented in the original and flipping their order. Any questions there? So, a graph question. This graph is the original function. And then I'm asking you questions about the inverse. So if I say f inverse of 2, so this means that 2 was the y value in the original. So what I'm asking you is to find x when your y equals 2. So if I go to my graph, when y is 2 is right here. What's the x value? 0. So f inverse of 2 would be 0. B, f inverse of 3. So on the original, 3 was the y. So I have to find my x when y was 3 on this graph. So I go to my graph, when the y value is 3, we're right here. What's the x value?
8.
Is it? Yeah, I think it's 7. Kind of hard to count from a distance. Those all kind of blur together. So f inverse of 9 means find x when your y is 9. So we're looking right here, so that is 9. So just reading the graph backwards. All right. Have you on your minds? Bored you to death?
Yeah.